Boolean algebra. Let's begin first with the history. Na-develop ang Boolean algebra noong 1854 ni George Boole. Ano nga ba ang Boolean algebra? Boolean algebra, it deals with binary variables, logic operation. Ang binary variables ay ang 0 at 1. Ang logic operation naman, ito yung mga logic gates na kung saan ay ang not and or. Boolean variables represented by binary numbers 1 and 0. At ang 1 represent as true and the 0 is represent as false. Elementary algebra utilize conjunction, disjunction, and negation. Ang conjunction ay and ito yung sinasabi kong end ng logic gate. Disjunction naman at ang negation is not. Or conjunction, nagiging true lang siya kung yung both statement is true. And disjunction naman is false if only both statement is false. And negation is if the statement is false, then the negation is true. Or if the statement is true, then the negation is false. Next, the primary modern use of Boolean algebra is in computer programming, like the binary code. Next will be postulates and theorems. Postulates is the statement accepted to be true, no need to prove. And theorems is the statement that we're thinking that is fact, but we need to prove that the statement is fact. This area is the or operation, and this area is and operation. That's the history and introduction of Boolean algebra. So let's begin now with the sample problem.
And his name is...
Let's prove that this is equals to yz plus y prime z prime plus xy prime. First, identify the common terms. Here, we can write this as yz times the quantity of x plus x prime. Also here, we can write this as y prime z prime times x plus x prime. Since there's no common terms, we can just write it here, x, y prime, z. Since x plus x prime is equals to 1, we only left with yz plus y prime z prime plus x y prime z. There's a common term here which is y prime. We can write it as yz plus y prime times the quantity of z prime plus x z. This is equals to z prime plus x based on the absorption rule. So, we only left with yz plus y prime times the quantity of z prime plus x. We only need to distribute this. So, we will have yz plus y prime z prime plus xy prime. Let's check if we prove this one. That's the answer. Thank you.
With the hair, better beware, cause everywhere she be, I'ma be there like, hello, my name is...
So now let's prove that this equation is equal to b prime of c using Boolean algebra. We distribute this ab prime to this equation. It will become ab prime c plus ab prime bb multiplied by c equals to b prime of c. B prime of b will be equal to 0 because postulate 5 states that x prime multiplied by x will be equal to 0. So ab prime c plus a multiplied by 0 b plus a prime b prime times c b prime of c. We can now distribute this c. ab prime c plus this now will become 0 because of the multiplication property of 0 says that any number or variable multiplied by 0 will be equal to 0. Let prime b prime c is b prime of c. Here we can say that c multiplied by c equals to c because of theorem 1 states that x multiplied by x is also equals to x. Can we write this as ab prime c plus a prime b prime of c equals to b prime c. Now we can combine like terms. B prime of c multiplied by a plus a prime equals to b prime of c. B prime c equals to b prime c. Therefore, this equation is correct.
Nung kailangan kong gawin.
Hi, it's now my turn to show you my example.
Prove that a plus b multiplied by b plus c is equal to a multiplied by c plus b. If we look closely, we see something like that in the distributive property, which says that a plus b times c is equal to a plus b times a plus c. And that's kind of the same with what we have, except a plus b times b plus c. So what I want you to notice first, that in each of these parentheses have the same variable. Next, we have to do is take a plus b and our b plus c and rewrite it so that the first thing in both parentheses is the same, which means we're gonna have to switch around the first set of parentheses to write this as b plus a times b plus c. And that's going to be using the commutative property of addition. Now that we've made the first thing in each parenthesis the same, we can now undistribute so we can get b plus parenthesis a times c. Using our distributive property. Now that we almost get what we want to get is ac plus b. So all we have to do is now use the commutative property to rewrite this as a times c plus b. And that gets us the equivalent that we want.
It's up to you now, guys.
君の虜になってしまえばきっとこの夏は充実するのモード
We will give another example about Boolean algebra, which is this equation proves that this is equal to 1, and this is already the solution that I've written earlier. So I will explain now the process of the solution that equal to 1. So let's start. So first, AB distribute in the inside of the bracket. These variables can be a Morgan law, which is A prime plus B prime plus C prime. So you can see there's three possible theorem number 1 and one complement theory, which is A times A prime is equivalent to 0, which is complementary. So, and theorem number 1 is B times B is equivalent to B. Will be these whole variables will be included as 0. So the theorem in theorem number 1 is A and B. So A times A is equivalent to A, and B times B is equivalent to B. So here in the third equation, the remaining variable will be solved by the absorption law, which is C prime and AB, which is X plus XY, X prime, which is equivalent to C prime, which is here, and another is A prime and A times BC, which is X prime plus XY, which is equivalent to A prime plus A, which is here. Another absorption is A prime times A times BC is equivalent to C plus A prime. Another theory is C, which is here, C prime plus C is equivalent to 1. Identity law, theory number 2, which is X prime plus 1 is equivalent to 1, which is here will be cancelled by 1. And another A prime plus 1 is also the identity law, which is equivalent to 1. So that's the solution for the equation here to prove that this is equal to 1. That's all for the group 6, and thank you for watching. Bye!